Welcome students. In this class I thought I can show you some mathematical fallacies which people commit knowingly or unknowingly for the interest of trapping others or making ridicule of others, or probably they are not aware of the fact that they are breaking mathematical law. Now you have to understand that there is something called as the mathematical law. Now mathematical law cannot be broken. For the simple fact, it is like breaking the gravitational law. What happens if you try to break the gravitational law? Say, imagine that you climbed to the 120th floor of a tall building, and you say that, wow, I'm going to break the gravitational law, and you're standing there and you're jumping from this 120th floor, thinking that you are basically got rid of the gravitational law. What would be the consequences? I need not have to tell you the consequences. I am sure that you are well aware of the consequences. So, similarly, mathematical law should be preserved at all times. More so, we are living in a world what is called as the digital world. And digital world is not a virtual world. It is a reality, in fact. Now, why am I mentioning this? Because all of the digital components, digital applications, digital interactions have a mathematical law behind them. Okay, having said all these things, I came across a proof which is claimed to be a proof that 4 is equal to 5. Right? Now, this is not possible at all. But the author says 4 is equal to 5, and at the end of the video, the author wants to know what exactly went wrong. Alright, so there is a question mark. So I'm going to show you what exactly went wrong. However, you are free to pause the video and think what is the problem here in this particular proof. So foremost, the author says, do you all believe that 0 is equal to 0? Yes, we all believe that 0 is equal to 0. Of course. Now, can I write 0 as 20 negative 20, the left side 0? And can I write this 0, the right hand side 0, as 25 negative 25? Yes, you can write. Now, can I write 20 as 4 times 5 followed by 4 times 5, and this 25 as 5 times 5 followed by this negative sign, and this 25 to be as 5 times 5? Yes, of course you can do this. Now, since I see a 4 here and a 4 here, can I take 4 out? Yes, you can take 4 out. And can I rewrite this as 5 negative 5? And similarly, can I take this 5 out and rewrite it as 5 negative 5? Yes, you can. And then the author says, since there is 5 negative 5 on the left hand side and 5 negative 5 on the right hand side, I can clearly cancel these two components and state 4 is equal to 5. Now the question is, where did I go wrong? That is up to you all to find that out. You can pause the video and think what is the exact mistake, and you can probably give the perfect reason in the comment box. I can give you, say, 30 seconds time, or you can pause the video and write down the solution. Not more than 30 seconds. I hope you all have got the solution. Now, the big mistake that the person does here is, now we have got all of these things are okay. Okay, all of these things are okay. You are free to do this. But coming to the point where 4 of 5 negative 5 is equal to 5 of 5 negative 5, now the person goes and cancels these two components. Now, when exactly you can cancel this? What is happening behind the scene? Now, apparently the problem is, whenever you have, say, 5x squared is equal to, say, 25, people simply go out and cancel 5 and 5, and then they just place it like this. But this is not the story that is happening here. What is happening here is, you got this 5 times x squared is equal to 25. Now, to get that 5 here, what are you doing? You're dividing both sides by 5. That is what is happening behind the scenes. So 5 times x squared divided by 5 is equal to 25 divided by 5. 5 gets cancelled, and 5 divides 25 5 times. So I can say x squared is equal to 5. This is what is happening. What are you doing? You're dividing by 5 both sides. That is exactly what is happening. Now, in this case, if you want to cancel 5 negative 5, what should you do? You are dividing both sides by 5 negative 5. Okay, this is what is happening. But can you do this? What is 5 negative 5? 0. Can you divide by 0? Can you? Mathematically, you cannot. You cannot do that. Of course, you are hiding the fact that you're dividing by 0, you're masking it by placing 5, negative 5. That's what is called as masking. The technique of masking. The truth is being masked. You're brushing the truth underneath the mat. You're actually dividing by 0, but instead of saying it as 0, you're saying 5, negative 5. Because whenever you divide a quantity by 0, it is undefined. Okay, have that in mind. So the mistake is you cannot cancel this off for the very fact that you are invoking the division by 0, which breaks the law. What law? The mathematical law. So once this mathematical law is broken, that's it. Everything is chaos. Everything will result in chaos. Whatever algorithm you are designing, suppose you have such ideas in your mind, whatever algorithm you are designing, it will lead to pandemonium of problems. So have that in mind. So that is the mistake that the author has done. Now, point number 2. Now, method number 2. Now, you can also simultaneously bring out something like this. So, this is also relevant. This is also a proof. But this proof is a little bit different from the one that I showed you. In this case, we are going to show the same thing, 4 is equal to 5, but a little bit different. Now, the proof starts off, the author starts the proof in this fashion. Now, you all believe that negative 20 is equal to negative 20. Yes. Okay, fine. Now, can I write negative 20 as 16 negative 36? Yes. Now, can I write this negative 20 as 25 negative 45? Yes, you can do that. Now, can I write this 16 as 4 multiplied with 4 and this 36 as 4 multiplied with 9? Yes, you can. Can I write this 25 as 5 multiplied with 5? Yes. And this 45 as 5 times 9? Yes, you can do that. Now, can I add to this component? 81 divided by 4 on both sides. So I'm adding 81 divided by 4. So what is this? This is actually, I'm going to rewrite this. This is actually 4 squared negative 4 times 9. And I'm adding 81 over 4. So this is 5 squared and 5 times over 9, and I'm adding 81 over 4. So this is perfectly possible. And it is acceptable. Now, the point now comes is it okay that I can rewrite this? Okay, let this be a 4 squared. I want to rewrite this as 2 times 4 times 9 over 2. So this is actually 2 times 4 times 9 over 2. Is it okay? Because 2 gets cancelled. It's actually 4 times 9. And can I write 81 over 4 as 9 over 2 raised to the power of 2? Yes. Now, can I write this as 5 squared? Can I write this as 2 times of 5 times of 9 over 2? And can I write this as 9 over 2 raised to the power of 2? Yes. 2 gets cancelled. 5 times 9, 5 times 9. So it's perfectly fine. Now, this is looking like, to me, a negative b whole squared. What is a negative b whole squared? A squared negative 2 times ab positive b squared, right? So I'm going to use this and rewrite this as 4. In fact, 4 negative ab. So I got a. My b is going to be 9 over 2, right? Whole squared. So 4 squared negative 2 times a b positive b squared 9 over 2 raised to the power 2. That's okay. So this, can I write this as 5 negative 9 over 2 whole squared? Yes. Okay, now what the author does is, okay, I'm going to take square root on both sides. So taking square root on both sides, taking square root both sides. Okay, the radical sign and the square gets cancelled, radical sign and square get cancelled. So what do I get? I get 4 negative 9 over 2. Right? On the left hand side 4 negative 9 over 2. On the right hand side 5 negative 9 over 2. negative 9 over 2, negative 9 over 2 gets cancelled, so 4 is equal to 5, right? So where is the mistake? I'm sure all of you would have found the mistake. Okay, the mistake is it's visible there. So I give you 30 seconds time for you to spot the mistake out. So you can pause the video and think about it. Okay, have you got it? Okay, the mistake is over here. This is the mistake. This is okay, because 5 negative 9 over 2, this will give me 1 over 2. So let me just show this. Let me use the space over here. Probably I need to use some more space. 5 negative 9 over 2. What is this? 5 negative 9 over 2. This is 10 negative 9 divided by 2. That's going to be 1 over 2. Now you're taking the square. That's fine. 1 over 2, you take the square, and then you can get 1 over 2 here. This is fine. When you take the square root for this, it's fine. You're getting 1 over 2. Okay. Now from the left hand side, you get 4 negative 9 over 2. And you're taking a square root of this. This is the problem here. This is the problem. You know what is this? This is 8 negative 9 over 2. That's nothing but negative 1 over 2 square. Now negative 1 over 2 square is going to be positive 1 over 4. Then you are taking a square root of this. Then it gives you 1 over 2. Now this is fine. 1 over 2 is fine. But you have got no business to use a negative value inside and then take a square root of that particular quantity. Why? I'm going to show you why you can't do this. Why you can't do this, I'm going to show you. Now imagine you got root of 49. Now square root of 49 is root of 7 squared. That's fine. Now root of 7 squared gives you 7. It gives you positive 7, nothing else more. It doesn't give you negative 7. I'll tell you the reason for that. Now what people are doing is, alright, this is 7 squared, so let me write 7 squared as 2 negative 9 raised to the power of 2. So 2 negative 9 is what? Negative 7. I square it, what do I get? When I square 2 negative 9 raised to the power of 2. In other words, you are actually squaring. You are squaring, what is this? Negative 7 raised to the power of 2. When you have completed the execution of squaring it, then it is perfectly fine. But what they are doing is, they are preventing the completion of the squaring process and interjecting it with the operation by the radical sign. And they are now neutralizing this operation of 2. This power operation they are neutralizing with the radical sign by interjecting it. And then they are saying a root of, then they are saying this is negative 7. Right? This is what they are doing, because they can simultaneously show that negative 7 is equal to positive 7. Say for example, I can very well write the same root of 7 squared as say root of 9 negative 2 raised to the power of 2. Right? So I can just, let me just show this to you. Say everybody knows root of 49 is equal to root of 49. Right? So what is root of 49? This is 7 squared is equal to 7 squared. Right? But on one end I'm going to write 7 as 2 negative 9 raised to the power of 2, right? And this end I'm going to write 9 negative 2 raised to the power of 2, right? This one is going to give me 7 squared, right? But this one is going to give me negative 7 squared, right? Then say negative 7, and on the right hand side the radical sign and square gets cancelled. Oh, negative 7 is equal to 7. This is what their claim is. But this is actually a big contradiction or a fallacy in mathematics. You know why? Why? Because of the very fact that the square root function, I'll tell you the reason. The square root function is a single valued function. Okay? You try to draw the graph of f of x is equal to root of x. You try to draw the graph. It is a function. What do you mean by the term function? Let me just tell you what is the meaning of whenever you say f of x is equal to root of x is a function. It means for every x element of capital X, there exists a y element of capital Y. Okay, such that x goes to y alone. That's all. So you cannot say root of 49 gives you positive 7 and or negative 7. This is wrong. It never gives you -7. The person who has shown you the proof should allow the completion of the squaring. So when it is squared, you get root of 1/4. And when you operate on with the radical sign, then you get only 1/2, positive 1/2. You never get negative 1/2. So the fallacy lies over here. Because if you permit like this, you can literally, you see here? Can you see here? What did I do? I have shown you here. -7 is equal to 7. Imagine people are going to be using concepts like this to write algorithms. It is going to be a complete chaos in the digital world. So the mathematical law should never be broken. And more so, as people studying mathematics, it becomes imperative that we are aware of the pitfalls that people try to throw at us. So that is the main reason for me to bring this video to your attention. Students, thank you so much.